Get going with our first presenter for the day. Up first, we have Ken Rost from Frost Inc. He has been with Frost for a while and has been working with Winfield to push his products and services into the golf market. Ken, thank you for joining us today.
Well, thank you, Kevin, and thanks to everyone else for joining us here today. Um, these technologies are surrounding us in our regular daily life, with constant upgrades and phones and things like that. So it's about time that our spray equipment caught up with those technology advances. So hopefully we'll be able to answer some questions here. And I saw a lot of questions come in ahead of time, and I think that the presentation is going to help answer a lot of those. But if you have questions that aren't being answered through the presentation, please do put them up on the Q&A, and we'll address them toward the end of the presentation. So thanks again for joining, everybody. So what we're going to talk about is really kind of the technologies that help us execute accurate and the best sprays possible. The presentation, I kind of liked the way that Winfield organized this. The things that Dr. Straw is going to talk about as far as decision making and variable rate applications, that's very much a component of what we consider precision turf management. But there's also the data collection part of it that Gary and Zeke are going to bring. And we didn't want you to listen and absorb that information with the big question in your mind, well, how are we going to execute these applications? And so we're going to answer that question right away by showing you the equipment and the technologies that help us execute what we would call precision turf management. And I kind of label things as smart if they're smarter than I am. So we're calling this smart sprayer technologies today. And I've had the benefit of working with this really over the last, now we're going on our 9th year of installing GPS systems on sprayers and spray equipment. So it's this isn't something that's coming. It's really what is here and what is possible now, and hopefully we can help you get over some of the barriers for adoption. So we're going to talk about what smart sprayers are. Really, it's a combination of different technologies, and we're going to talk about rate control, guidance, individual nozzle control, and also what is the dual nozzle control. We're just going to define each of these individually and see how they kind of all come together into a complete system that helps us execute applications very precisely and accurately. So starting out, we're going to talk about rate control. A lot of us probably started our spraying career on a machine like this, where we basically have a switch to turn on a master and maybe 3 boom sections and a pressure control switch that will basically raise and lower the pressure that we can see. And that works in some situations. For example, let's say that we have white 08 nozzles on our spray boom, and we want to apply 1 gallon per 1,000, and we're going to be traveling at 4 miles an hour. Well, I can look at a chart or an online tool and say, okay, well, I need to have my pressure at 21 psi. And so we make sure that we set our pressure to 21 psi, and we can go ahead and do that application. Problem is what happens if I change my speed? And if I go up to 5 miles an hour, I'm going to have to increase this pressure up to 34 psi. If I go up to 6 miles an hour, I'm going to have to know that I have to increase that pressure to 48 psi. Now, on a machine like this that's got a manual transmission, holding speed is is not that difficult. You know, it can be done, but it creates an inefficiency. For instance, if we have, you know, a hydrostatic drive and we're able to change speeds, or, you know, apply at a faster speed, which we all seem to want to do, you know, this can be limiting. So the concept of automatic rate control has been around for quite some time, going back probably around 25, 30 years now. And really it brings in the opportunity of controlling the rate automatically, regardless of the speed that we have. And we do this with a couple of extra instruments on the machine. We have a speed sensor of some type. Today we're using GPS speed sensors because they're so inexpensive and reliable. We have a flow meter in the system that's recording and measuring how much flow is actually going out of the nozzles. And we have a regulation valve that is actually controlling the flow going out of the nozzles, and a controller that's basically doing the math many times per second to make a decision whether or not flow needs to be increased or decreased to keep a target rate. Pretty complicated systems internally, but the result is it very much simplifies the operation for the operator. Now, one of the things to consider here too, and we'll touch on it a little bit farther down the road, is that in addition to changing the flow relative to our speed, it also will change the flow if we turn off a section or two sections. It will reduce the flow out of the overall system so that we aren't then pushing that extra flow through the third boom that's still open. So there's multiple reasons why this rate control is important in accurate applications. The question is it worth it? I'd say, yeah, a resounding yes. This is something that any sprayer that has the opportunity of trying to do accurate and precise applications should have a form of automatic rate control as part of it. Now, a second component that makes up a sprayer that's going to be what we consider a smart sprayer for executing precision applications is the concept of having guidance. And guidance is basically, we're all familiar with the concept of satellite positioning and connecting to satellites to give us GPS positioning wherever we are on this Earth. And it will show any area that we've done an application, and it will show any area where we have not done an application. This is an important feedback for the operator. It also pretty much replaces what we would use as far as like a foam marker for marking out and giving the operator indication about where they have done their applications or how to do a pass-to-pass. Having guidance allows us to create boundary lines, and this is one of the pre-questions that came up. You know, how can we map out or prevent applications over waterways or water drain areas, things of that nature? Well, we simply can create some boundary lines around those areas, and we can either create them to be sprayed areas or they can be designated as no spray areas. So guidance is the feature that allows this to happen. And the next thing that guidance allows us to do is actually create maps and upload maps that allow us to either change rates or only spray in certain areas based on a prescription that we've sat down and previously designated. And we'll get into that a little bit more in a few minutes. Probably one of the most important things that having guidance on a sprayer or GPS type of guidance on a sprayer does for us is it allows us to record spray jobs. Now, if you think about it, if we don't have this ability and you send out a spray tech and, you know, he's been with you for maybe 10 years and you trust him, you've seen the quality of the turf after his applications and everything, you know, your relationship with your spray tech has developed to the point of great trust. But say that that spray tech gets an assistant job at a golf course down the road, and you have to bring up a new spray tech. You don't necessarily have that same trust and knowledge that he's going to execute those applications the same way that your original spray tech did. But having records of spray jobs and showing where sprays have been applied and the data that we're seeing right here, as far as how many gallons, how many square feet of application, all that is, you know, useful information for training, as well as just having records of the job in case you are audited by a regulatory agency. So is it worth it? Yeah, I'd say definitely worth it. This basically can change a whole program by now having this type of opportunity of application through GPS guidance. Whenever I talk about guidance, I always seem to have to bring up and talk about error correction. And error correction is necessary because the transmissions between satellites and our receivers are traveling through the ionosphere. And the ionosphere is a layer of our atmosphere where all the Earth's magnetic fields are operating, as well as influences from solar flares and things of farther in our galaxy. And they have the tendency of slightly bending the radio waves as they travel through that ionosphere. And what happens is that we get what's called drift, or GPS positioning drift. So we have to come up with some sort of error correction redundancy to minimize those errors and improve our repeatability. Now, the first group of error correction services have been around for quite some time. WAS is basically a system developed by the FAA. DGPS is basically a technology that allows multiple satellites to help position or improve the accuracy of location. GLONASS is another Russian constellation of satellites that we've recently gotten access to. And what we're looking at here is, you know, on a pass-to-pass basis of 4 centimeters, that's right around 2 inches. That's pretty good. But our accuracy on a day-to-day basis can be off by as much as 1 meter. And so if we created a boundary today and wanted to spray it tomorrow, we can expect a random positioning of anywhere from 0 to 1 meter off from that position. So in turf, you know, some might say, well, is it worth it? And the answer is yes, because all of these services that I just showed here are free. There's no cost other than the cost of the hardware to access and use these services to create this pass-to-pass of 4 centimeters, but 1 meter on a day-to-day basis. So because it's free, it's worth it, and it helps us create a base that we can work from. Now, the second layer or level of error correction is a service that we use called TerraStar Pro. And it's a service that's provided by a company called Hexagon that has basically installed geostationary satellites above us. So unlike these satellites that are the ones that we see in the night sky that are traveling across the sky, these geostationary satellites will look like nothing but a star because they are parked over us and they aren't moving. And so ground referencing is done directly to those satellites, and there's basically then a radio wave that's sent to us as a mobile vehicle that adds to this WASP layer of air correction and allows us to have a pass-to-pass accuracy of 1 centimeter and a day-to-day accuracy of 2 centimeters. That's pretty good. I'd say that, you know, if we create a boundary today and we wanted to spray it out tomorrow or the next day or the next month, if we're within 2 centimeters, that's pretty good accuracy for our turf applications, especially when we consider that the resolution of our nozzles on most sprayers is a 20-inch spacing. So is it worth it? Yeah, for the accuracy, for what we're trying to do now, it's definitely worth it. And what I will say here is that this mid-level service that we're showing here, TerraStar Pro, this is where a lot of the advancements have happened in the last, well, even just the last 3 years. This Smart 7 receiver that is what we're running now to run TerraStar service is super fast, and it is able to reach out to multiple geostationary satellites, so that in the past, if we had a tree line that was in the way of whatever geostationary satellite that we were connected to, with the previous Smart 6 version, we would see interruption from that. But now with the Smart 7s, it's reaching out to multiple geostationary satellites, and we're not losing signal like we did with the previous generation. So I think that was one of the questions that people had pre-asked about is, you know, if they had a GPS sprayer already, you know, how do I prevent or stop this interruption of service around trees? Chances are you have an older style or an older version of receiver. Again, these receivers just in the last 3 years have really improved the experience of the operators and minimized, if not eliminated, lost signals. So the next level of air correction is again layered on top of the existing, and basically it's connecting to the ground reference stations and adding a signal to the machine through, you know, originally it was through ground tower radio waves, but now we're transmitting through the cloud using SIM cards in the receivers to take on additional air correction. That's called RTK, and it's a very popular air correction style in agriculture, mostly because RTK was developed by the US Coast Guard and Border Control, and it came up into the United States through navigation of the Mississippi River. So towers were set up around the Mississippi River to help guide barges with great accuracy to avoid collisions with sandbars and obstacles on the Mississippi River. Well, because those towers were there, agriculture started to use those same towers in the Mississippi Delta to create air correction and precise GPS positioning in their agricultural operations. So RTK has been very popular in agriculture. That's kind of how it came into the market. And quite honestly, a lot of the systems that are being used on sprayers today came from agriculture. And so RTK was one of the services that was originally offered and is offered by a lot of OEMs and spray companies or spray technology companies. The question is RTK worth it? There is an extra cost to the operation of RTK, and it can be anywhere from $10,000 to $20,000 to add that as an air correction. And if you look at the improvement in the day-to-day accuracy, we're gaining a centimeter of improvement. So is that 1 centimeter difference between TerraStar and RTK worth it for the extra expense? And I'd say that of several hundred spray systems that we have out in the market, probably 80% of them are using a TerraStar system, and maybe only 5% of them are using RTK, and the other 5% is probably still just using the WAS. So we're seeing, at least in our customer base, a more adoption and acceptance of the TerraStar error correction over RTK. So hopefully that kind of explains that for people and answers some of those questions. Now, like I said, a lot of systems that are on the market that are being kind of shoehorned into turf started their life in agriculture. And recently, we've seen a lot of companies kind of leveraging auto steer into the turf market. You know, you can understand, okay, John Deere's had quite a presence in precision agriculture for a number of years. And when they put a GPS system on a turf sprayer here recently, they just automatically assumed that everyone would want auto steer as well. So that's part of their offering is an auto steer for the turf machines. The question is, you know, is it worth it? And I'd say it's a big question mark there, because you can understand in agriculture, if you're going to try to plant and spray and harvest perfectly straight rows, auto steer makes a lot of sense. But in turf applications, very rarely are we working on flat, square type areas. And when we have individual nozzle control for spray applications, keeping a perfectly straight line isn't as important as it used to be, because those nozzles will turn off. But I can see that auto steer would be valuable for some other operations, such as mowing, or in the athletic field, maybe line painting, things of that nature. So as far as I'm concerned, for the expense, is it worth it? I think it's still yet to be proven that it's actually worth it for turf applications. And incidentally, all of these technologies that I'm talking about are technologies that Frost offers to any customer. It's part of our systems. And so it's not that I'm poo-pooing something that isn't available through Frost. It's just that we haven't seen the adoption and the embracing of the industry, at least the turf industry, that is, you know, compared to, for instance, the agricultural industry. The same goes for telemetry. Telemetry is something that's been brought forward in agriculture in the last 5 years. And, you know, as far as being able to, for instance, share spray application from one machine to the next machine, so that 2 machines can be spraying and operating in the same area. Well, in agriculture, that might make some sense. If 2 machines are working on the same field, maybe they've got a nurse trailer that's supplying them, so they're kind of alternating their positioning. But in turf, it actually presents more opportunity for problems and interference for one machine over the other working in the same space. So direct telemetry is I'd say, more of a value proposition for agriculture, but less of a value proposition for turf, because there are some inefficiencies that start to develop when 2 machines are working on a smaller area. But both of those technologies, including this technology, are all made more possible with the more accurate GPS positioning. That's kind of what I want to make sure that we focus on is that the positioning of machines, our sprayers and what have you, is more capable through the TerraStar or the RTK type of accuracy and repeatability. And that also leads to the opportunity for robotics. Now we're starting to see it in mowing operations, but I doubt that we're going to see it in spray applications, mostly because of that pesky little thing called regulations, where licensed operators need to be on hand or need to be controlling the equipment that's doing the applications. So I see some barriers to this. If it were possible, would it be worth it? I'd say yes. Obviously, labor is a big issue facing us in the market today. And anytime that we can automate things or robotically control things, we're going to be saving on some of that labor. Toward the end of the program here, I'm going to kind of introduce you to a technology that's probably going to leapfrog past the opportunity of robotic spray applications. So hang on for that. All right, so the next part of a smart sprayer, now we talked about automatic rate control, we talked about GPS guidance and positioning, and we should understand that pretty well. Now let's talk about the other concepts of the actual applications. And individual nozzle control, I think everybody should be pretty well understanding of what that is. Obviously, if we have an operator without individual nozzle control, he's got 3 booms and he's going to travel across this green. He's got to make a judgment whether or not he's going to allow overspray over his intended spray area, or if he's going to turn those booms off earlier and underspray that boundary line. So the individual nozzle control obviously allows for more accuracy in application. And when we first started putting spray systems together in 2012, about the only value proposition that we had for people, just because we didn't have the experience with it yet, was product savings. And it shouldn't be hard for people to understand that if we have a smaller resolution of nozzles crossing over a boundary line, and we're able to turn those on and off independently versus a full boom, we're going to see product savings. So everything recognized in the orange colored area is a potential product savings. So when we first brought the systems to the market, all we could do is kind of estimate what the product savings were. And our early adopters of these systems were told that, we hope that you can gain, a 10% product savings. And that was just an estimate. In a minute, we'll see kind of where that led. But individual nozzle control must have rate control as part of it. There was a flash in the pan GPS individual nozzle control system that went on the market about 4 or 5 years ago now. And all we're doing was turning on and off nozzles across a boom over a boundary line. And that all works fine. But they weren't integrated into the automatic rate control. So what would happen is if this boom over here was turned off, or these nozzles were turned off, the sprayer didn't know it and tried to push that extra volume out the rest of the nozzles that were still open, therefore over applying on the area where the nozzles that were still open. So they tried some patch fixes to it, never got it figured out, and they left the market. So that's an example of why individual nozzle control must have rate control part of it. Also, it needs to be automated. Obviously, that makes sense. We can't expect an operator to be managing 20 switches to control nozzles independently. We need the automation part of it. So is individual nozzle control worth it? Yeah, definitely. And we'll go over kind of the results of this here in a minute. But first, I want to kind of, I want to look at the different types of devices that are out on the market. And I'll again tell you that we have all of these types of devices available at Frost, but there are some pros and cons to each one of them. The first one that we see here is a micro ball valve that's threaded onto a nozzle body. This is the system or the device that's used by John Deere. It's brought to the market by Hypro, and you know it's a pretty simple and very well-designed device. Is it worth it? I put a question mark here just because I do the fact that it is not limited in its flow. The ball valve opens completely, and it's not prone to getting plugged up or anything like that. So that's all very good. However, we're limited because we can only operate one nozzle at a time, and that's going to be more, we'll go into that in quite a bit more detail in a minute. Another type of control system that's on the market is a central valve bank. And on this piece of equipment, they have, this is the GeoLink system on a Toro sprayer. They have 20 nozzles on the boom, or I'm sorry, 12 nozzles on the boom. It's a 20-foot boom. And they have what's called a central valve bank. So these back here are 10 valves that are operating 12 nozzles across the boom. So how does that work? Well, the controller can only operate 10 outputs. So what they had to do is they had to pair up 2 nozzles on either side of the rear of the machine. And then they have individual nozzle control out on the rest of the boom. And, you know, I can understand why they did that. Most of the individual nozzle control on and off is going to happen out on the wings. It's just a decision that they had to make. But there's drawbacks. There's hoses. They don't have the hoses shown in their rendering here, but there's a hose from each one of these valves going out to each of these nozzles. And when you have that much hose in line, the delay or the lag effect from an on and off command here is going to show hydraulically different for this outer nozzle versus the inner nozzle. And it very much affects the accuracy of your application, especially if you're at speed. So there's some drawbacks to this. Number one, it's not actually full out of individual nozzle control if you're pairing up 2 in the back of the machine. And you miss out on some of the other benefits as far as the lag time, and then we'll talk about dual nozzles as well. So I hate to talk negatively about anything, but this system, as far as the individual nozzle control design, is inferior, and it does affect the performance of this machine. Individual nozzle control solenoid devices. Now, this is on another OEM piece of equipment. So these devices are solenoids. That means they are a copper coil with a charge and a magnetization of a plunger that's being drawn back to open up a port for the nozzle. They're very similar to an injector in a fuel injection car. The problem with these is that, number one, they're limited in their flow capacity because the opening in the orifice is relatively small. It has to be designed small relative to the size of the electromagnetic coil. And they're also prone to plugging. So these devices, while they can work with, you know, nice soluble chemistries at fairly mid to low rates, at mid to low speeds, when you get up into higher rates and higher flow situations, they can be limiting. So these devices, again, we have the opportunity of using them if people want to use them, but they aren't our first choice. So we're just going to leave those as a questionable. What I do like about this system is that they have 2 nozzles on each nozzle position, and I'll talk about that in more detail coming up. This type of device is what is called a DCV, or a diaphragm check valve. device. It's a stepper motor that's basically pushing back and forth against the diaphragm to open and close. And we like these devices because they don't limit any flow. They are not prone to plugging. They just don't plug. They don't operate like a solenoid where they take power to open and then get weak over time. These just are going back and forth, back and forth, back and forth. And they only consume power when they're in that transition mode. So the reliability of these devices is what we like very much. So the last kind of component or feature of what I call a smart sprayer is having two nozzles at each nozzle position. And really what that does is it opens up a lot of things for us. So if you consider this to be our two nozzles, A and B, we have one nozzle that will come on at a certain speed and it'll switch to a larger nozzle for a faster speed. But then even at faster speeds than that, it's like having a third nozzle where it's A plus B. And that speed range allows for reduced drift, obviously, because we can go at faster speeds and not try to push all that volume through one nozzle that's going to atomize more droplets and create drift. But it also relates very much to more productivity. It also allows for variable rate. And we're going to talk just a little bit. I'm just going to kind of do an overview of variable rate. I'm not going to get into detail because I'm going to let Dr. Straw do that. But if we look at, for instance, this spray area here, and say, for instance, we're trying to apply a gallon per thousand in this zone and 1.5 gallons per thousand in that zone. And let's say that we have an 08 nozzle on our sprayer, and in the orange or the yellow zone, we're spraying along at 48 PSI. But if I go into my 1.5 gallon per thousand zone, that one nozzle would have to go up to 109 PSI to be able to deliver that rate at that same speed. So what we do is by adding a nozzle or giving a computer the opportunity of adding another nozzle, that brings that spray pressure down, if we're adding like an 06 to it, to 34 PSI. So the transition pressure going across this zone, the difference in pressure is a lot less than that 109 PSI. So the computer is able to make that transition a lot quicker when we're crossing over this transition zone. So the dual nozzles gives us just a wider range and more options for the computer to choose a nozzle to hit the target rate at whatever speed we're traveling. So is it worth it? Most definitely. For variable rate and for productivity, if nothing else, dual nozzle control is tremendous. So the results of having a smart sprayer and all these technologies combined together, automatic rate control, GPS guidance, individual nozzle control, dual nozzle control, our results from our customers has been reported 8 to 17%. When we hit the market in 2012, we told people that we expect you should be around 10%. So we're above our target, and this is real information from customers. This is not a projected number. And this has been documented as well. I've been fortunate to work with a number of universities across the country. Dr. Frank Rossi at Cornell did a report and study, and that 17% number is on his report. We've provided them with a sprayer, and they're still doing research with it now, but that white paper documents that 17%. And if anyone wants a copy of that, of the report, I'm happy to provide that in PDF form. But the biggest thing that our customers report back to us is the increase in productivity, primarily due to that dual nozzle feature. Just being able to do applications at, instead of crawling along on a fairway at 4.5, 5 miles an hour, doing a 1.25 GPK application rate, these guys are able to do that same application rate at 9, 10 miles an hour. That gets the sprayer off the course quicker, keeps you ahead of play, keeps your equipment, your spray techs off doing other jobs. And then more accurate sprays is the other result. Again, working with groups, for instance, Dr. Bill Kreiser at University of Nebraska, Lincoln, really highlighting the effect of overspray of PGRs on collars and approach areas. His justification for the system is almost purely built on the prevention of that collar decline and with the more accuracy and minimized overlap, and better drift control as well. Very much an important part of it is having these application records, and our systems are able to be transferred to an operator's phone, and they on their phone can forward it or share it with anybody. And the platform for viewing these is Google Earth, and you can view all of these applications and all of the application data just on Google Earth. You don't need any special programs to be able to do that. And I mentioned Dr. Kreiser at UNL and his Greenkeeper tool. We're happy to report that we've worked with them, and they are now able to store all of these application records in that Greenkeeper app on their servers, so that you have all of the data as far as weather data, your tank mix data, all your growing degree day information obviously is there on that tool. And now you can keep the records for this. So if you get audited by a regulatory agency, all you have to do is hand them this information and they will be definitely impressed. It just makes for a better spray program. So is it worth it? Everyone that has our system, definitely, it's worth it. So we can answer questions about numbers at any point, but this is what the results are that you will expect using a GPS guided smart sprayer. So very quickly on variable rate, I'm not going to go in detail on this, but because Dr. Straw is going to kind of take this over, but concept-wise, we're just changing a rate according to a prescription, and we do it by collecting data, and that's going to be the guys, Zeke and Gary. They're going to show us ways to collect data, and then we make some decisions. That's where Dr. Straw is going to step in, and then we execute it, and that's where this presentation on precision application equipment addresses that execution. So I usually split data up into different level categories, ground level data such as soil moisture, compaction, nutrient levels, ground penetrating radar here. We're going to hear from Zeke about that. These are all things that, that we can collect for data on the ground. Then we have high level data that's available to us from drones like Greyhawk and Gary's program, satellites, ground sensors. Basically, we're just trying to identify areas of high vigor versus low vigor. So an orange area might be an area of lower vigor. And in this case, we can see some things that we can't see with our naked eye, or we maybe wouldn't see from the ground. But for instance, this area was a reconstructed bunker that now there's turf growing over it. Well, obviously the soil profile underneath that is different than the rest of the fairway. But these, this imagery and this type of data that we can get is predictive, and we can execute applications to help protect that turf prior to it going into a suppressed position. So once we have the data, we need to make some decisions. And obviously, we're looking at coming up with some different rates for different zones based on their input needs. Obviously, we need to stay within label. And some states allow some deviation as far as underspraying on a label, but some states like New York don't allow that. So we have to be mindful of what's on the label, obviously. And then it will depend on what type of application we're making. You know, fertilizer, fungicide, wetting agents, obviously we can do variable rates. PGRs, I don't know if we're going to be doing variable rate with PGRs, but maybe Dr. Straw at some point will have some input on that. So it will depend on the type of application. And I will say that this is where we've had kind of a mixed feedback on variable rate applications. Courses that like to put the kitchen sink in their spray tank and send it out and do multiple modes of action or multiple inputs at a time, maybe aren't going to want to separate out a wetting agent application to do a variable rate map. And then we have other superintendents that don't have a problem with that at all. So it's really kind of a preference thing. However, we are paying attention to that, and I think we're going to be coming out with some technologies that will appease both groups of superintendents. So keep tuned for that. Basically, then after we make those decisions, we create a shapefile with the GIS program, and that's a service that's offered by a lot of companies, or you can learn and get proficient with a GIS program to create those on your own if you want. But most of the time, our superintendents are sourcing that job out. So to execute, basically, we have to have these characteristics of a smart sprayer. We upload the files and basically go out and drive over the areas with the master switch on, and the computer takes over and does the rest of it. Simple as that. So what the results are, in addition to the savings that I mentioned before of just having a smart sprayer, adding variable rate, most of our operators are telling us that it's greater than 15%. 15% is the lowest number. About 30% on some applications is the highest number. It improves our environmental impact and kind of shows people that we've got an advanced practice for operating. Is it worth it? Yeah, I'd say it's worth it. So what's next? This was one of the pre-questions that came in. Yes, we can set up GPS control on spreaders and different types of equipment if it has a hydraulic control. So the system's able to control the belt speed to change the rate, control the spinner speed to change the width, and very accurate. We've done some collective tests on this, and we're just unbelievable. Not too many people realize that, you know, a top dresser like this can be used for fertilization. And the other thing is that the most expensive component is the receiver, and not always very rarely are you doing fertilization at the same time that you're doing spray applications. So a lot of our customers will borrow the receiver off from their sprayer to go out and do this type of fertilization, and the overall cost for the system is greatly reduced then. And yes, we can do variable rates with that. Other equipment like walking green sprayers like this, the opportunity of minimizing overspray. You know, if you're trying to do 100% application on a green, at some point inside of that boundary, you're going to be overspraying and over applying because you have to travel over an area that you've already sprayed. But with the GPS system on this, we're able to minimize that and increase the accuracy, especially on a device like this where it's 80 inches across and there's no opportunity of turning any of those nozzles off. They're either all on or all off unless it has GPS. And on this system, each nozzle has its own on and off. And here again, that receiver could be shared from another sprayer and makes that system pretty affordable. This is our next step, and what I mentioned before about robotics, this technology is going to leapfrog probably past the robotics portion of spray applications. This is an opportunity where we can be very selective and specific about an application. So for instance, if we have a breakout of a grass species that we've identified and we've been able to go out and map, we can deploy the drone to do an application directly on that spot. And instead of just broad applications across the whole course, we can do it very specifically. And these drone flights are autonomous. We basically set up the shapefile or the map in it. We deploy the drone as a mission, and it goes out and executes the mission and comes back. There is a radar on this machine. This is a machine that we just purchased, and that is for object and ground contact prevention. So that radar system enhances and allows us to be autonomous. However, to do this type of application, you can't just go out and buy one of these drones and do it. There are FAA rules, and there are extra licensing on a state-by-state basis to be able to do this. There's an umbrella FAA license that's necessary for the organization, and that's why we've partnered with Rantizo. I encourage you to look up Rantizo drone spraying on YouTube. You'll see a lot of applications there. Pretty cool. But then any of the operators operating the drones also need to have an FAA license. And so here at Frost, we've got a couple guys, myself included, that have gotten that license. And, is it worth it? The question mark is there only because we haven't done any applications yet, and we're excited to start this year. So if you think you would like to do this on maybe some specific applications, if you're in our area, we'd be happy to partner with you and kind of test out the feasibility of this. Otherwise, we'll report on it next year as far as how well it worked this summer. So the last thing as far as what's next is more industry adoption. And hopefully that's why you folks are on board here today, is to learn about the precedents. Again, we've been doing this since 2012. So you are not guinea pigs anymore. These technologies make sense. The other thing that we have to keep doing is the collaboration with research, and that's why I'm tremendously excited to work with Dr. Straw at Texas A&M. They have our systems down there, I think, on a couple of sprayers, or one sprayer for sure. I mentioned Dr. Kreiser at UNL. Again, worked with them for quite a number of years. Dr. Rossi at Cornell, also at the University of Minnesota. And we also have sprayers at a number of technical colleges as well. So we have to bring this all together in order for people to get the confidence to be able to execute these types of technologies. And what I like to think is that if we use the best technology at our disposal, and the industry is recognized for that, that hopefully we can hold off whatever pending regulatory prevention might be coming down the road. So it's part of a best management practices type of philosophy. I kind of went through things fast there at the end. Hopefully I answered a lot of questions. If you want to see some videos, obviously check out our YouTube channel.